Now that we've defined infinite limits, we're going to look at some examples. Okay, so first let's use our graphing calculator to kind of explore. And the functions that you're going to see most often where this happens are rational functions, or functions that have a denominator. And these are going to happen when the denominator is equal to 0. Okay, so our function value won't actually be valid there. We won't have a function value, it will be undefined. But our limits from the left hand or the right hand side will be going up toward infinity or negative infinity. Okay, so let's go ahead and graph, move this up a little bit, graph 1 over x. Okay, so here's our graph of 1 over x, and we want to look as the limit goes to 0 from the right. So we're going from the right, and we see here it's going up toward positive infinity. Okay, so this limit we would write it as infinity. Now, just to kind of logically think that out, if we're above 0, we're coming from the right, that means we're plugging in positive values. And as we're going towards 0, we're plugging in things that are getting closer and closer to 0. So think like 0.1, 0.001. But these are all positive values. So they're getting bigger and bigger and bigger. But that value 1 over something positive would have to be positive. So that's how we can know that it's going to be positive infinity. Okay, let's look at this next one. We want to do 1 divided by, we'll have to put this in parentheses, x minus 3. So we know 3 makes our denominator 0. It's not in our domain. So that gives us a good indication that we're going to have a vertical asymptote here. And if we look at the graph at 3, now your calculator may not have this. The vertical line there is our asymptote. It's not actually part of the graph. But as we come from the left, we see that it's getting negative. And so our limit here would be negative infinity. Now, again, reasoning this out, if we're coming from below 3, you could think of putting things like even 2 in. If we put in 2, we would have 1 over 2 minus 3, we would get negative 1. If we put in something like 2.5, we'd have 1 over 2.5 minus 3, we would have negative 2. And these numbers would get more and more negative. Okay. Okay, let's look at 3x over 2x plus 10. Okay, and we know that negative 5 makes the denominator 0, so we'd have an asymptote there. And here we're coming from the left, and we can see there that the graph is going up toward infinity, so we'd say infinity. Now, again, just testing something that's a little bit less than negative 5. So if we tested, say, negative 5.5 and put it in there and saw are we getting a positive or a negative number, then you can see whether it's going to be a positive infinity or a negative infinity. Okay, so we're going to do that with a few more examples. We can make what's known as a sign diagram, or we can look at the graph. Here we want to do the limit as x goes to 4 of x squared over x minus 4 to the 4th. Now, plugging in 4 does make our denominator 0. So if we just want to make a sign diagram and put 4 on it, we want to kind of test points on either side and say, okay, what's happening to the graph? So if we put in something a little less than 4, we could even do 3. So let's use our table just to help us out. So if we put in x squared divided by x minus 4 to the 4th. Okay, now putting in something like 3, right, we'd have 9 over negative 1 to the 4th. Now, negative 1 to the 4th is a positive number, 1. So we'd get a positive number on this side. Okay, and if we go to the table, okay, and put in 3. Oops, sorry, I don't have this on ask. Okay, so we could put in something like 3, 3.5, 3.9, things that are below 4 but getting closer and closer. And we can see this is getting big very fast, and then they're all positive numbers, okay? So here we could say that we know from the left of this function it's going up to infinity. Well, let's look at what's happening from the right. So we need to choose things bigger than 4. So we could do something like 4.1, 4.01. And you can see these are also positive numbers that are getting very, very big. This one's so big it has to use scientific notation. Okay, so this one's also positive. So we could say that the right-hand limit is infinity, and we could say that this limit is infinity. Okay, here we have 3x plus 5 over x plus 2. Okay, and we know that we have vertical asymptote here at -2. So if we pick something less than -2, like -2.1, okay, we see that we get a positive value. Okay, and then if we pick something bigger than -2, so maybe -1.9, just on the other side, we see that that's negative. Okay, so the sign diagram can help us because now we can say that the left-handed limit is equal to infinity, while the right-handed limit is equal to negative infinity. And then we would say this, again, since they're not the same, we would say this, the limit itself does not exist. Okay, let's look at one more. So here we've got the limit as x goes to 1 of x to the 6th divided by negative, and then to get the absolute value we're going to do math, go over to number that ABS is our absolute value, x minus 1. And we know that something's happening at 1 here. So if we put in something less than 1, like 0.9, okay, we get a negative number. What if we put in negative if we put in 0.99? Okay, that's a bigger negative number than 0.999, a bigger negative number. So here from the left, this is going to negative infinity. Now, how could you reason that out? The numerator here, x to the 6th, no matter what you put in, is going to be a positive number. The denominator here, no matter what you put in, since you have an absolute value, that's always going to be positive, but you're multiplying it by a negative number, so that's always going to be negative, and a positive divided by a negative will always be negative. So without even kind of putting numbers in here for bigger than 1, we know it's going to be negative. So here we know both limits, the left-handed and the right-handed limit, are going to go to negative infinity. So we can say that this limit is equal to negative infinity.